Hi, it's Rob Fisher from Redstack here. Thanks for joining us for today's webinar on Autodesk vehicle tracking. We're very lucky to have Andrew Milford presenting for us today. He's been travelling around the country doing a whole bunch of these presentations, so he'll be well on top of it all by now, I'm sure. Andrew's got some great experience. He's been with Autodesk for about a year, but has extensive experience in industry, working as a civil designer, a visualization specialist, and working on a lot of uh, road and highway projects with MX, 12D, and Autodesk products. So he comes with some great experience, and I hope you enjoy what he's got to share with you today. So, Andrew, I'll hand over to you. Just so everyone's aware, we are recording the session and you'll get a link to that recording. If you do have any questions or comments as we go along, then you can type those in and I'll monitor those as we go, but we will just take most of the questions at the end of the presentation. So thanks, Andrew.
Thanks, Rob. Yeah, as Rob mentioned, I've been with Autodesk for about 12 months now. Prior to joining Autodesk, I've spent about 20 years in the design industry, as Rob says, working with software products such as MX, 12D, and most recently Civil 3D. So what we're going to talk about today is Autodesk Vehicle Tracking 2016 and how we can actually use it in our road design and geometric design process. So before we move on, just a few ground rules in the webinar. If you have any questions along the way on what you've seen, just type them into the questions box or the chat box down below, and either Rob or myself, either during the session or at the end, we'll get around to those and answer the questions for you. So in the agenda today, we're going to be running through the three distinct modules that make up Autodesk Vehicle Tracking. Vehicle tracking actually comprises three separate modules. Now, primarily, most people think of vehicle tracking as a 2D and 3D swept path tool. With the 2D and 3D swept paths, this includes features such as vertical clearance. We've got really good interaction with Civil 3D surfaces, as well as a lot of animation and reporting tools. We're going to cover some of the parking layout tools, and we can show how quickly and easily we can set up and edit parking layouts in a fraction of the time it takes using traditional CAD methods. And thirdly, we'll look at AVT's junction tools, showing how we can build up complex preliminary roundabout design, and then we can edit and refine that after the initial placement. And then we're going to finish by converting that 2D roundabout layout into a full three-dimensional Civil 3D corridor with simply the click of a button. So just to give an overview of Vehicle Tracking 2016, this is actually a recent addition to the Autodesk range of engineering design products, and it was formerly known as AutoTrack from Savoy Computing. So since purchasing about 2 years ago, Vehicle Tracking has undergone tight integration into all of the AutoCAD range of products. So it's designed to work seamlessly across the AutoCAD range. Just to give an idea, vehicle tracking, as I mentioned before, it began as AutoTrack, which was initially sold as 9 separate modules. As you can see here, we've got Roads Pro, we've got rail modules, so we can actually start to look at doing light rail and train swept paths, parking layout tools, junctions, airports, and any kind of aerospace vehicles, AutoTrack Templates Pro, and AutoTrack Review. Now, AVT combines all of those modules into a single design solution. So there's no additional need for module purchase. You get all of those 9 modules straight out of the box. So before when I mentioned integration with the AutoCAD products, AVT is compatible with 2014, 2015 and 2016 versions of all of those CAD softwares that you see. So anything that supports the AutoCAD platform, that's products in the infrastructure design suite, AutoCAD architecture, Plant 3D, Map 3D, AutoCAD utility design, of course, runs on standard AutoCAD as well. So we're just going to move in and look at some of the more detailed aspects of the software. So we'll start with the swept path tools. So before we begin, just the vehicle library with Autodesk Vehicle Tracking ships with over 1,000 different vehicle types. And as you can see here, most importantly, it actually ships with all of the relevant OSRAID standards dating back as far from 1995 right up to the latest 2013. We also include Australian standards, or AS 2890.2, for our vertical clearance envelopes, as well as other aircraft and support design vehicles. We have all of the US standards, AASHTO, Caltrans, so literally thousands of vehicles. And the great thing about it is we can actually have the ability to even edit our own. So this is just a small list of some of the types of vehicles that actually ship with AVT. And if there's a vehicle you'd like to analyze that isn't included in the predefined library, vehicle tracking gives us the ability to create custom types of any vehicle. That's anything from single unit vehicles up to multiple articulators. So as you can see, we're not just limited to cars and trucks, but any kind of steered vehicle. You can see in our transportation space, we can look at things like low loaders, heavy haulers, aeroplanes, helicopters, delivery trucks, right through our architecture space where we can start to look at delivery trucks, wheelchairs, mobility scooters, even down to refuse trucks. And it can even be used in the plant and manufacturing space where we can start to look at swept paths of forklifts and autonomous guided vehicles. So we're really catering for any vehicle that promotes steered movement. So this is just a quick video on how we can actually start to edit and create our own vehicles in Autodesk Vehicle Tracking. So what I'm doing here is actually selecting a design vehicle from the OSRAID's 2013 library, and all we do is simply select the vehicle we wish to copy. As you can see here, the library is actually very extensive. So we can either create a new vehicle from scratch, or it's really just easier to take a copy of an existing vehicle and start to modify its parameters. So you can see here we can start to change the actual distances between axles, how many wheels per axle, the size and shape of the body. We can even add 3D models to those vehicles to make them look more compelling when we move to a 3D view. So what I'm doing here is just editing a copy of a 19-meter semi, and we can give the source of the data and a description. So in this case, I'm going to take a 19-meter semi. I'm going to keep it as 2 separate units. You can see I can change things like the front track width, the number of front axles, the rear tracking widths. Most importantly, we can change the wheelbase, and this all affects the vehicle when we go to apply it into our AutoCAD drawing. You can see here it's a very simple wizard interface. It's very easy to use. Once the model has been set up, we can then save it back off to our library and reuse it over and over again. So even though we're just setting up our vehicle using a wizard here, you can see we're changing the number of axles, the distance to the kingpin. You can see it's actually been saved now in our drawing pool. And what we can do now is actually go into the advanced editor and start to fine-tune those parameters even more. So you can see there we can actually start to change the steering types. As I said, there's a lot of parameters in here we can start to dive into. So most, if not all, infrastructure projects, especially, I know for the ones I worked on in industry, they require some sort of swept path analysis to determine if the proposed roadway geometry can support the movement of the various vehicle types. So vehicle tracking lets us do this really quickly and easily. The software provides immediate feedback to the horizontal space required to maneuver our various vehicle types. So all we really do is select the design vehicle we want to use. We simply point and click and start to track our swept path along. Once we have our swept path in place, we have the object is an intelligent object which has grips that we can easily edit and refine the vehicle path as the changes are made, and these results are dynamically displayed and updated in your viewport. So the way we go and create these swept paths in AVT, there are many different drive modes that create these swept paths. The most straightforward being the auto drive arc, which lets us freehand in the swept paths. We simply point and click to set the driving direction of our steered vehicles. The auto drive bearing allows us to set specific turning angles to specify the swept path. The manual drive uses a kind of dynamic interface to let us control the vehicle interactively, much like you would a real vehicle. The guided drive is used for trams and other light rail vehicles where the position is driven by a rail layout. And the follow method, which lets us track a vehicle along a predefined polyline, spline, or even a civil 3D alignment. And we can actually combine these methods with each other to create some complex driving modes. So the auto drive arc, this lets us freehand in swept paths. This lets us freehand in the swept paths. We simply point and click to set the starting direction. You can see here I'm just selecting the vehicle to use, setting it as the default vehicle. And all we do is simply come, auto drive arc, select our starting point and its rotational start point. And all we do is just start to point and click and set the driving direction, and away we go. So you can notice as we select alignment, we can force the path onto a bearing. So what I'm doing now is selecting turn onto a bearing, pick an alignment, and actually just selecting an AutoCAD line, I'm actually going to snap that object and align it to that bearing. It just assists us in setting out those swept path movements. You can see there we actually clip the curve. So what we can do is adjust the exit overturn angle and readjust it to suit. And we still have a conforming swept path. So it's just a great tool to check that geometry is suitable for that design vehicle. We can even actually undo segments mid-section. And you're noticing here what I'm doing is after the swept path is in place, I'm actually still able to edit that path. The auto drive bearing tools. This is where we can start to use the simple point and click method, and in the middle of that, flip over into an auto drive bearing mode. So what I'm doing here is starting a swept path in the opposite direction, and I'm starting out just using some of the freeform tools. But what I'm doing now is I'm actually going to turn onto a specific bearing. I know in this case the angle is going to be about maybe 78 degrees, and it locks that bearing as we go around the corner. And then we start to take off again back to our freehand arc tools. You can see here I'm actually grabbing the start of that simulation. I'm actually just going to drag it up a little bit just to tidy up the documentation. So you can see there's a lot of power in these tools, but they also give you very accurate results to the designs of those swept paths. So this swept path here, this is actually a combination of many different drive modes, and you'll notice we can actually even perform reverse maneuvers. So what we do is once again come up to our auto drive arc, and we're just going to freeform up until we hit the intersection. We select our design vehicle. In this case, we're just going to use an 8.8 meter service vehicle. So what I'm doing is now, I'm just doing a freehand arc. I'm now going to pick that alignment and snap it to that bearing. I'm going to pick another alignment, snap it to another bearing. So you can see we can build up some really complex maneuvers really quickly. What happens is as I move my cursor back, we're now actually going in reverse. And I'm now going to reverse it in to that bearing. So it not only caters forward movements, but it caters for backwards as well. Follow path drive mode. This lets us actually use a predefined path. It can either be an AutoCAD line, a polyline, spline, or a civil 3D alignment. So once again, we use our simple design tools. What I've got here are some construction lines. I know I want my vehicle to follow this specific path. This is actually really easy to do. All I'm doing now is selecting my default vehicle again. In this case, I'm going to probably use a 8.8 meter service again. And all I do is say, follow a line. And using the 19 meter semi, all I do is pick the end I want to start at. I can specify design speed, and that'll actually affect the turning radius of the vehicles. As well as we can look at some dynamics as well. As you can see there, that swept path follows right down the center line of that alignment. So you can see there's many different ways we can actually perform our swept path maneuvers. So creating an animation in vehicle tracking is as simple as selecting your specific swept path and clicking on the animate button. So in doing that, we simply select it, we hit the animate button, and it's just a simple panel that actually flips us into a 3D mode where we can start to set up our camera and our target points. Now this is just a visualization of the simulation itself. You can see here I'm actually setting up a fixed camera position. So we can actually set up dynamic cameras that follow the vehicle, or we can actually set up static cameras so we can view it all from a single viewpoint. As you can see, we can just watch the vehicle performance maneuvers in 3D. So we can then assign and create a movie with one or more vehicles working in conjunction with one another. And we can start to adjust the timings and create some compelling visuals directly within the AutoCAD environment. And then we can actually export those recordings out to AVI for further review. So vehicle tracking has been designed with simplicity in mind. It's all about simple workflows. It's all about, we have the capability of a one-click vehicle-to-ground conflict detection. It actually works very well with civil 3D surfaces. Now, if you look at this low loader as it comes across the curb here, each wheel is actually reacting independently to one another as it mounts the curb. So this gives us great visual feedback that that design vehicle will not actually conform to the geometry. Vehicle tracking also has the unique ability to interact with native civil 3D objects directly, including surfaces and alignments. So in other words, none of our time is wasted performing conversions every time we want to run a 3D analysis. Instead, we just focus on the design itself. So as an example, you can see on the bottom left image here, we're actually utilizing the civil 3D surface to perform a ground conflict check, so we can see what extent the vehicle is actually going to impact the roadway. These are hard-coded values into Autodesk vehicle tracking. So you can see there we have the green areas saying that we have between 50 and 100 mils of ground clearance. We're starting to get a little bit close there. We're in the yellow areas, which is between 0 and 50 mils. When we start to get into the purple and red, we know that our vehicle is actually going to be scraping into the design surface. We're also able to create civil 3D sections through critical areas, and we can see those just in the middle of the screen there towards the right. So it's just a video on how we perform the ground conflict checks. It's very similar to how we do a standard civil 3D swept path. We just simply hit insert ground conflict report. It goes and creates those clash contours for us. So as soon as we move our alignment, we just regenerate those contours. It's a very quick process. It gives us confidence that that our design not only works in 2D but in 3D as well. And that's just an example of some of the critical sections, showing how close the vehicle is getting to the pavement. So this is just a quick video showing the creation of a swept path. And this is using a combination of the freehand arc and some alignment set out. So we're doing a freehand arc at the moment. We're now going to snap to the alignment. So we follow the alignment's bearing around the corner. And you can see here we're starting to just sort of clip the curb there. It looks pretty close. So what we're going to do now is just flick across, make a quick animation of the simulation. I'm just going to adjust my camera and move around to get a better vantage point. You can see there we can move from side to side, we can adjust the height. And as we go around the corner, you can see the design vehicle, that rear wheel is actually mounting the curb. So we can see immediately that we need to fix something there. That vehicle cannot get around. So AVT is actually creating a true 3D analysis of that swept path against the civil 3D surface. What I'm now doing is going back into civil 3D, and I'm actually just increasing that curb radius. So in this case, I'm just quickly adjusting that curve return within civil 3D. I'm just going to adjust the tie-in locations, rebuild that 3D model. You see that's a very quick process to undertake. just grabbing a few grips, tying them up, and that's it. We've rebuilt the 3D model. Now we can actually go back in, re-perform the analysis, and confirm that everything works. The vertical clearance tools in vehicle tracking, this let us check the vertical profile for clearance checks to make sure that our vertical alignment curves are long enough to cater for the design vehicles. So what we're doing here is we're actually using a civil 3D profile to do a vertical clearance check. Now I'm going to select the alignment here, but being true vehicle tracking, we need to actually set the vertical exaggeration to 1. So it doesn't work on vertical exaggeration. So we're just changing the style in Civil 3D, making sure it's 1 to 1. We select the vertical clearance button. All we do is select the alignment. We're going to check the defaults. And as you can see, there's our swept path for our 19-meter semi. So we can come back now and we can actually start to insert vehicle outlines at critical locations along the alignment, just to show those points. So this is a really great tool if you're doing, say, driveway profiles, and you want to see if the vehicles are going to scrape and bottom out. The vehicle clearance tools are just what you need in that case. And vehicle tracking finally lets us display our swept path analysis using a variety of different unique visual styles. So you can see here at the moment we've got some hatching on this type here. You'll notice we have different coloured hatching for both the forward and the reverse manoeuvres. So in this case, using the Drawing Explorer, we can turn off our hatch body envelopes, redraw, and you can see we're just looking at the swept path outlines. There are a lot of different parameters in here. We can start to display things like construction lines. We can show our body envelopes, and we can change the colours and the layers and the line types of all of those different elements. So what I'm doing here is just turning off the clearance envelopes. So many different reporting functions. I'm just going to change some of the body outlines. So you can see the envelope here. Currently it's green. We're just going to change it to a different colour. Hit redraw and it updates on screen. And we can actually save these reports off and use them as our company templates. You see we can add things like visibility sight lines. Once I hit redraw, you can see how far around the corner we can look. Now we can actually specify those sightline distances either by a hard-coded value, or we can actually base it upon the design speed of the swept path. You see that everything updates dynamically. We can even start to show profiles that associate to the swept paths, as well as things like turning graphs, so we can actually start to look at things like our lock-to-lock steering times. Vehicle tracking also lets us insert our planned turning templates for our design vehicles directly into our AutoCAD drawing. So this is useful, and we can use these templates as part of our presentation or for our verification documents. So what we're doing now is just using a simple wizard. This lets us add our turning templates into our AutoCAD drawing. We're just going to collect that drawing from the pool that's currently sitting in the drawing. We can actually either add these onto the screen, or we can print them directly to a PDF. So I'm just limiting the turning rate. As you can see, I can add all of the different turning angles. You see I'm going to add a few extra ones in this case. So all we have to do is select the relevant design vehicle, and we start to progress through the wizard. We select the multiple turning angles, what elements we're going to display, the wheel track envelopes, the curb offsets, and all it's going to say is select the insertion point, and it goes and builds out a simple 2D overlay for us. So once again, just a great tool for those design verification docs. Moving into the layout tools, Autodesk Vehicle Tracking contains features to optimize road and intersection geometry with regards to both roundabouts and parking layout tools. So we have some editing options on these as well. These create dynamic, single geometrically constrained objects that change and are dynamic. So as we move them around using a series of grips, they will actually realign themselves according to specific design standards. We can also define our own standards or check against the standards that ship with the product. So we're going to look at the second of the modules now in a little bit more detail, the parking layout tools. So traditionally, when we set out a parking lot, we want to maximize the number of parking lot spaces and still maintain something that is actually operationally functional. So vehicle tracking contains all the tools we need to optimize the layout as well as maintain the geometric standards that we can set with regards to bay widths, driving aisles, even handicap spaces. We have editing options available to us as well. So as we make changes, we can see the dynamic nature of the objects as well as their adherence to design standards. So firstly, we begin by actually selecting the standards that we wish to apply to the parking layout. You can see there we support standards for all of Australian standards, 2890.1, 2890.6, as well as US and British styles. So in this case, we're selecting the parking lot standards we wish to use, in this case Class 1, employee and commuter parking. And we start to simply just select a parking row. So I'm just going to drag that into the pool and use that as our base. And we can actually start to edit the parameters if we wish. We can change all of the parameters in there with regards to line styles, colors and hatchings. We can start looking at things like the bay width dimensions, the island dimensions. In this case, all I'm going to do is select it, and I'm going to simply hit OK. So we typically begin our car parking layout by first selecting our design standard, and then we can look at adding things like rows, where we can start to specify bay types, bay angles, flow directions. We can look at parallel rows that remain linked to a parent row, as well as some grip edit tools. So creating a new row, we just come up and select create a new row, and it gives us the option as to what type of alignment we're going to select. There are some parameters down here that say whether we want to work left only, right only, or look both ways, or go both ways. And all we do is simply start to point and click and start to lay out our bays. So if we forget to set some of these parameters initially, we can easily go back. What I'm doing here is just laying it out. As I hit enter, you can see I can choose whether to add rows to the left or to the right. What I'm doing now is using some of the grips and just adding curves. And you'll notice as I move them around, the software is actually automatically adjusting the bay sizes and optimizing the number of bays. What we're doing here now is actually looking at adding an additional row in the middle here. So we simply just point and click to create our row, and we're going to select both sides in this instance. Now we're going to add a parallel row. So we select the parent row, and you'll see that as I go to create the parallel row, it won't actually let me move any closer. It's actually using the aisle width rules to drive the geometry. Now we can actually start to pick up our bays and start to stretch them. Once again, really simple tools, very powerful to use. You can see here we can add skews, and all the bay sizes adjust accordingly. So all of our rows are in place. All we're doing now is just going back and just adjusting our layout with the on-screen grips. I said a tool like this saves hours and hours of work. This process would traditionally take probably the better part of half a day, probably even a full day to generate this. And then when it comes to amending, you have to go and delete them all, run the whole process again. It's a really, really good time-saving tool. The bay editing functionality, this lets us change the behavior and display of any individual bays. So we can start to customize individual bays. We can add blind aisles, handicap zones, wheel stops, shared areas. So here's our preliminary layout. We want to start to add things like, you can see in this case, we want our bays to line up a little bit neater. So what we're going to do here is just simply change the bay alignment style, hit OK, and everything lines up again. We can start to change our island widths, minimum island widths. You can see here there's a bit of additional line marking there we don't really want to keep, so we just come in and start to play around with the parameters. In this case, I'm going to change that offset to the adjacent bay to 0. We can change the minimum width of curb, hit OK, and the model updates. Now these are just dynamic 2D CAD elements at the moment. we can actually use these, all of these line markings in later software packages. What I'm doing here is actually changing the bay to a disabled type. As I select it, you can see it's actually given us a specific type. Now what I can do is actually edit that specific bay type. So what I'm doing is I'm going to add a safety zone. So I've got a bay style here called disabled, and it consists of the parking meters, the bay markings, the bay symbols, and the safety zones. So you can see I've just changed the color of it, made it black, a little bit easier to read. And what I'm going to do now is copy that bay style to all the different bays I want to put it into. So it's really just that easy to adjust and edit in vehicle tracking. Now what we haven't catered for in this case are things like shared zones. They're traditionally wider bays, so we need to actually go back into our edit tools, and under our bay styles, we're going to add a safety zone here. We're going to add a new safety zone, give it a new name, change its line style, I like to have it black, and I'm going to put maybe 0.6 for the driver and for the passenger and share it across the zones. So now I go to my bay styles and assign that safety zone to that bay style. Hit OK, and as you can see, the whole layout has updated to accommodate that specific bay zone requirements. So as you can see there, it's not a case of creating something and then having to delete it and recreate it again. It's a full parametric object that lets us build up these objects, lets us build up our car parks, once again, very quickly, and we can start to really play around with what-if scenarios. Bay numbering in vehicle tracking. This is simply a matter of selecting a relevant bay type in the Parking Explorer. So we select the bay type in the Explorer here. And we're just going to select the bay type, and we're just going to select number the bay. We'll do that for both the disabled and the normal type, and we're going to add some wheel stops as well. We hit OK. As you can see, we've added automatic bay numbering to all of our bays. So should our design change, those numbers will automatically recalculate. So once again, a process that would take hours to do with traditional CAD methods, we're literally doing automatically in seconds with vehicle tracking. The Parking Standard Explorer, this is where we start to change, we can change the overall bay width, and this allows us to automatically update the entire parking layout in one go. So here, we're going to actually change the default bay width from maybe 2.4 meters, and we might up that to maybe 2.7. Looks about right. We hit OK. Once again, you can see all the bays have resized to suit. Then we can actually report out the numbers of those bays, and it actually gives us a percentage as to how many of each different bay type we have in our drawing. Any subsequent changes we make to the layout automatically get updated in that report, which we can then export to a CSV file or put into our CAD drawing. And the third and final module, we're going to look at the junctions and specifically look at the dynamic tools available to us to quickly generate roundabout geometry. Vehicle tracking's got some really powerful features to simplify preliminary layout of our roundabouts. The rapid editing of a single geometrically constrained object makes it really easy and viable to explore multiple design options. So once again, similar to the swept paths and the parking layout tools, vehicle tracking uses these established design standards to create all of the necessary geometry, which traditionally, if done manually, is a very time-consuming process. We also have on-screen grip editing to ensure that the further refinements to the geometry can be made quickly and easily. So similar to the parking layout tools, the roundabout creation tools adhere to a design set of standards. So you can see some of the standards out of the box. I'll make note, new in 2016, ABT 2016, we now have full support for the Australian Austroads Guide to Roundabouts Part 4B, as well as support for all the British, US, Italian, Danish, American types. So, and like the parking lot layout tools, we can easily copy and amend any of these standards and create our own or those of your client's specifications. It's just a quick video on how we go about setting up a vehicle tracking roundabouts. What I'm doing here is actually using the Civil 3D tools to set up a coordinate system, and I'm actually going to set the driving direction to the left side of the road. This is actually quite critical in the way the roundabout tools work. So what I do is go to the Junction Standard Explorer here. You can see here's a standards file. In this case, we can actually create a new standards file from scratch. Now I'm going to create one called RMS Design for the Roads and Maritime Services here in New South Wales. Or we can just simply drag and drop an existing standard to use as a starting point and then just edit the geometry from a copied version. You can see we can actually go in and start to edit the parameters. So what I've done there is I've just drag and dropped a design standard in. You notice I can just come in and change some of the parameters. So you notice the diagram on the left side there showing us exactly what we're changing. So as I select a certain item, it highlights on the screen what we're actually editing. So it just makes things a lot easier to set up your design standards. Just simplifies that setup process a lot. And we can start to change all of our design parameters, like our inscribed circle diameter, our apron diameter and the widths, the circulating geometry widths, the approach and departure geometry with regards to curb return radii. We can adjust lane widths. We can even start to edit things like splitter islands and crossing dimensions. We can add things like rumble strips and crosswalks, footpaths. So there's a lot of parameters available to us in here. So alignments on the approaches to the roundabout can actually be anything from AutoCAD lines and polylines right through to Civil 3D alignments. Civil 3D alignments have the advantage that you can actually use the vertical geometry applied to those strings to actually drive the generation of an automated 3D corridor. So in this case, I'm just going to use some Civil 3D alignments just to create a quick crossing. And you can see just how quickly it is to set up alignments using Civil 3D's tools. So I'm just eyeballing in some geometry at the moment. Like I said, this can easily be fine-tuned at a later time. And this is actually going to form the basis of our roundabout design. So all I'm doing now is I'm going to create a surface profile along those Civil 3D alignment strings. I'm just drawing those in the profile view. So that's actually a dynamic profile we have there. What I'm doing now is actually designing the vertical geometry through that existing alignment. We'll do that for the second road. Now they don't have to actually intersect at the exact same point, but the great thing with Civil 3D is it just makes it so quick and easy to set up. Any changes we make are dynamic and they get pushed through all of the geometry that we create down the track. So laying out the roundabout is as simple as selecting, let the video explain it. Laying the roundabout is as simple as selecting the new roundabout button once we select our design standard. Not going to assign, we can assign surfaces for our final corridor. In that case, we're not going to create a 3D corridor straight away. We just hit OK from our settings. We can give the junction a new name and select what kind of drawing style we're going to apply. Then we simply click anywhere to place our center island. Now, it doesn't actually have to be exact the first time. What we now do is start to select the approach legs to the roundabout. We can give it a name or accept the default. And you can see there, Civil 3D, ABT, goes and builds out that roundabout geometry for us according to the design standard we applied. Now, this is a process that takes a ridiculously long amount of time in real-world practice. But the great thing with ABT is I can now select this roundabout. You can see what we're seeing there is performance data on the intersection. What I'm doing now is actually picking up the whole roundabout and moving it to a new location. You can see there all the performance data changes dynamically for each leg of the roundabout. I mean, traditionally, and you can see what I'm doing now is I'm actually selecting the roundabout and adding the fourth leg. So we can actually come back and start to add and remove legs at will. Once again, I can select that whole geometrically constrained roundabout object and move the entire thing around. That process of moving a roundabout from one side of the control line to the other would probably take about 6 hours to regenerate all that geometry using traditional AutoCAD methods. Here, we're just doing it all dynamically. So we have many edit tools available. So once our roundabout is in place, we can start to move things around with the grips, or we can actually start to move in to the design panel and start to play around with things like our splitter islands, crossings, rumble strips, and speed stripes. So you can see here's our roundabout object. As we select it, you can see there's a multitude of grips that come up. What we can do is just add a new splitter island. I select the roundabout and I select where do I want the splitter island to go. Once again, it uses the rules designed in the design standards, or I can now start to pick them up and actually move that geometry around on screen. Now, it's probably not the most accurate way to set out your splitter islands. There are generally offsets that need to be conformed to. So you can see in our junction properties box, we can now actually go down and start to edit the values of those and really start to fine-tune and get those in place. As I mentioned before, the design standards for Osro's Part 4B are now built into AVT 2016. Once again, as I move through those dialogues, you can see the screen highlighting on the left, showing us what parameter we're about to change and edit the values of. You can see here we can just simply add a new crossing. What I'm going to do here is just add a crosswalk through, and you can see, once again, all dynamic. I select an approximate location, move back into our edit tools, and now we can start to play around with the different types of crossing. The great thing is we can start to look at things like the width of the pedestrian crossing, what type of crossing it is, whether it's going to be signalised or unsignalised. You can see I'm lining up straight across the roadway there, adjusting a few different crossing angles. Now we can actually start to break the splitter island and add some refuge widths across there as well, and some offsets from the line marking to the actual curbing. So a lot of control over how we finally display this item. And once again, just demonstrating the parametric abilities, we're just able to add those to all 4 legs. Roundabouts and swept paths. Because the vehicle tracking is intelligent enough, it actually understands when a vehicle path interacts with a roundabout object. You see the parameter there in the bottom right image there. We can actually snap to our vehicle tracking objects. What this effectively means is we can now perform our swept path analysis, and as we move our swept path into the roundabout, you notice it actually snaps into place. So it's actually using the roundabout geometry to drive the swept path. Now I don't have to actually point and click through the intersection. I only have to collect my starting point and my ending point. And you can see it's automatically giving us a best path through that roundabout. So the great thing is we can do this for multiple legs and it'll track its way around. Great thing is I can actually pick up and move the roundabout now, and those swept paths will actually update at the same time, so we don't even need to reform the swept path analysis. So it's just taking away a lot of that redundant work. What I'm doing there is just reducing the size of the center island. I'm just doing that dynamically just to get an idea. So we've now got 2D roundabout layouts. Vehicle tracking provides a really simple solution to convert this into a dynamic civil 3D corridor. So in our junction properties box, we can simply move to the 3D corridor section on the tab on the bottom left there and simply select create alignments. So what this gives us the option, we can actually create profiles through our existing geometry. We also have the ability to create corridors, top surfaces, and merged surfaces. And what we're doing is maintaining a dynamic link to that underlying 2D geometry. So if we decide to move the roundabout or any of the legs, that 3D geometry will update accordingly. So you can see converting this to a 3D object, there's our 2D roundabout layout. What we're going to do is come up to our junction properties, come to 3D corridor and select the existing and final surfaces we're going to work to. We move to 3D corridor and say select alignments, and we're going to drape the corridor on the surface and create a top surface. What it's now gone and done is it's gone and built out a civil 3D corridor. And that corridor is actually now linked back to that 2D roundabout geometry. What I'm doing now is just using standard civil 3D tools, using the new 2015 offset target geometry points. I'm just going to tidy up some of that geometry to make sure everything joins up and snaps together. So as you can see there, with very little work, we've created a full 3D parametric roundabout. So we can actually adjust the levels through this roundabout using a tilted plane method. We can either create those levels dynamically, or we can do them through the dialog. So in this case, you can see I'm grabbing a grip on screen saying we've got a 2% crossfall in a specific direction. You'll notice as I move that in the 2D layout, the actual 3D model will update. Once we rebuild. So what I'll do there is actually just take that back, change the slopes again, make it a little less severe, make it about 2% overall cross slope. So in this case, it's actually creating just a simple corridor. What I can do now, you can see that there's no curb and gutter, there's no verge, no daylighting at this point in time. But what Civil 3D does, or AVT, is actually builds out those assemblies for us. So what I can do now is actually come into those assemblies and start to build upon those using standard Civil 3D tools. So in this case, we're going to add a simple curb and gutter. We choose what side we want to hook that onto. We can add a simple footpath on the back, as well as some final batter slopes, in this case 4:1 cut and fill. And as we do that, you can see on the screen there, everything's just updating in real time. Now, what I need to do is just set up some targets. I'm now going to copy those parameters to each leg of the roundabout. So just copy those again using the standard Civil 3D tools, and it goes and builds out the geometry for us. Copy, put it into place. Once again, really straightforward process. What I haven't done there is actually assign my final earthworks targets. Then we can actually come, assign our surface targets, fix up the batter slopes so we know where everything's going to daylight. It's just a really, really quick way to generate some pretty solid 3D geometry. In this case, that's our inner island. What I'm going to do here is just add a mountable curve in the center. In this case, just add it to that object. You can see it builds up the mountable curve. So we can start to add things like aprons and all the other geometry that it requires in the center island. Now with some final daylighting. Oops, need to put it the right way around. Delete that, put a new one in. Reassociate some targets, and there's a conceptual 3D model. We could take this through all the way to detailed design. We can disassociate it from its parents, disassociate it from its 2D geometry once we're happy with the set out, and then really start to fine tune and tweak our detail work. So that pretty much brings me to the end of the presentation. I said thank you very much for your time. If there's any time remaining, certainly if there are any questions, I'd be more than happy to answer some of those. So if you just add those into the chat box or the questions box.
Thank you very much, Andrew. Hope you enjoyed the presentation today. We will hang around for a few minutes and take any questions that might come through. If you need any further information on pricing, or you want assistance with obtaining and using the vehicle tracking software, or anything in that civil engineering space, then RedStack are here to assist you with all of that. So you can give us a call or email us, have a look on our website. Happy to assist you with whatever your needs may be. There's no questions come through at the moment, so we'll hang around for a few minutes and just see if any questions come through. Otherwise, thank you very much, Andrew, for your time. It was a great presentation, and I hope everyone enjoyed it, and enjoy your afternoon.